Hi children, welcome to Easy Physics. Let us make physics easy. Today I would like to take grade 9 physics, chapter 9, force and laws of motion, part 2. And we can start with Newton's third law of motion. According to Newton's third law, to every action there is equal and opposite reaction. To every action there is equal and opposite reaction. Let us discuss with an example. Let us consider two bodies A and B. Okay, A and B. That body A pushes B with some force. Okay, with some force. At the same time, B pushes A with the same force but opposite direction. Okay, here the body A pushes B, that is action. A pushes B, that is action. Okay, that is action. At the same time, B pushes A with the same force but is in opposite direction. That is reaction. B pushes A. That is reaction. Okay. So this is Newton's third law. In everyday life, we can see many examples for Newton's third law of motion. For example, while walking, we push the ground backward, right? At the same time, ground pushes in the forward direction. That is why it is possible to walk forward, right? So here, while walking, we push the ground backward, that is action. At the same time, the ground pushes in the forward reaction. At the same time, the ground pushes in the forward direction, that is reaction. Let us consider another example. While swimming, a swimmer pushes water backward with both hands, that is action, right? At the same time, water pushes him in the forward direction. Water pushes him in the forward direction, that is reaction. Okay. Let us consider another example. When a sailor jumps out of a rowing boat, the boat moves backward, right? This is according to Newton's third law. When he jumped out of the boat, that he pushed the boat backward, that is action. Okay. At the same time, boat pushes him in the forward direction, that is reaction. Now, while firing with the gun, alright, the gun move little backward. That is according to Newton's third law. Now we have law of conservation of momentum. We studied about momentum. Momentum is the product of mass and velocity. And what is law of conservation of momentum? According to law of conservation of momentum, total momentum before collision is equal to total momentum after collision, or the total momentum of a system is conserved. This we can prove it. So for that, let us consider two bodies of masses m1 and m2, okay, moving with a velocity u1 and u2 in the same direction. Okay, they are moving in the same direction. If u1 is greater than u2, if u1 is greater than u2, that means velocity of the first object is greater than velocity of the second object. What will happen? They will collide each other, right? Of course, their velocity will change, right? Then their velocity become. So after collision, they travel with a new velocity, that is v1 and m2, v2. Okay, so their velocity become v1 and v2. By Newton's second law, force is equal to rate of change of momentum. Rate of change of momentum. Force is equal to rate of change of momentum. Here, okay. Then F12. F12 means F12. Force exerted by 1 on 2. Okay. Force exerted by the first object, first body on 2. Okay. That is equal to rate of change of momentum. Rate of change of momentum of first body. Momentum of one of the first body. Okay. Right. This F12 is equal to rate of change of momentum of the first body, that is m1 v1 minus m1 u1, right, divided by t. Change in momentum of the first body means m1 v1 minus m1 u1, that is change in momentum. The rate of change of first body means m1 v1 minus m1 u1 divided by t. Okay. Similarly F21 means force exerted by 2 on 1. Force exerted by 2. Similarly, F21 means force exerted by 2 on 1. Okay. That is equal to rate of change. This is equal to rate of change of momentum of 2. Rate of change of momentum of 2. Okay. That is equal to F21 is equal to m2 v2 minus m2 u2, right, divided by t. Okay. So the change in momentum divided time. So F21 is equal to m2 v2 minus m2 u2 divided by t. Okay. So then by Newton's third law, F12 equal to minus F21, right? F12 is equal to, that means the force exerted by the first body on second is equal to force exerted by the second body on first, right? But it's opposite, that's why minus. F12 is equal to minus F21. Okay. So F12, what is F12? We have seen that is m1 v1 minus m1 u1 divided by time, right, equal to minus into, see, m2 v2 minus m2 u2 divided by t, right? Okay. So t we can cancel each other, right? So both sides. So here m1 v1 minus m1 u1 equal to m1 v1 minus m1 u1 equal to minus, okay, so minus m2 v2 minus into this term, so minus m2 v2, then minus plus m2 u2. Okay. So my m1 v1 minus m1 u1 equal to minus m2 plus m2 v2. Okay. Now bring same term into one side. Okay. So we can take this u1 term into the next side, and this one will be this side. Okay. This term you can take to this side. Okay. So m1 v1 plus this one, okay, m2, this minus will be plus, m2 v2 equal to, this taken next side, here it will be minus, okay, so m1 u1 plus m2 u2, right? So m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2, okay. Okay, now I am rearranging this equation. That means I am writing this term first. Okay, so m1 u1, okay, m1 u1 plus m2 u2 equal to this one, m1 v1 plus m2 v2 right? So m1 u1 plus m2 u2 plus is equal to m1 v1 plus m2 v2, right? Now what is m1 u1? Momentum of the first body before collision, right? What is m2 u2? Momentum of the second body before collision. Okay, so what is this? m1 u1 plus m2 u2, total momentum before collision, right? So total momentum before collision, right? For collision equal to, what is m1 v1? m1 v1 means momentum of the first body after collision, right? So, and m2 v2, what is m2 v2? Momentum of the second body after collision. Then what is m1 v1 plus m2 v2? Total momentum after collision, right? Total momentum after collision, okay. So that is, or we can write momentum is represented by which letter? P, right? So Pi equal to Pf, that is initial momentum is equal to final momentum. So this law is conserved, right? Or law is this, so this law is proved. So total momentum before collision is equal to total momentum after collision. That is law of conservation of momentum. According to law of conservation of momentum, total momentum before collision is equal to total momentum after collision, or total momentum of a system remain constant, or total momentum of a system is conserved. See that here we proved that total momentum before collision is equal to total momentum after collision. Clear? Now we have recoil of gun. Have you heard about the recoil of gun? So the backward movement of the gun during firing is known as recoil of gun. You might have noticed that when firing, that is the gun moving little backward, that is what is called recoil of gun, right? And you might have noticed that one more thing, that while that is firing, soldiers keeping the heavy gun that is close to their shoulder, right? So in order to avoid the injury due to the backward movement, so while firing the gun hit on the shoulder, right? So while if it is keeping closer, it won't move. So that is why, that is in order to prevent the recoil, so they are keeping the gun close to their shoulder bone, right? Now, so the velocity with which gun move backward, that is what is called recoil velocity. Okay, so recoil of gun means the backward movement of gun during firing is known as recoil of gun, and the velocity with which gun move backward, that is what is called recoil velocity. Okay, So let us consider a bullet of mass smaller firing with a gun of mass capital M with a velocity u. Okay, let the capital V is the velocity with which you can move backward. Okay, then before firing, momentum of the bullet before firing momentum of the bullet is equal to 0, right? Then what about the momentum of the gun? Momentum of the gun, that also 0 because before firing gun also not moving, right? Then total momentum before firing, that is equal to 0 plus 0, right? Then what about after firing? Momentum of, and we have seen that is what is the mass of the bullet, it's smaller, and with which velocity that the bullet is moving from the gun, u, right? So momentum of the bullet mu, right? After firing, momentum of the bullet after firing, that is mu. Okay, so momentum of the gun is equal to capital MV because mass of the gun is capital M and velocity, the recoil velocity of the gun is V, right? So MV. Then total momentum after collision is equal to MV plus MU, right? MV plus MU. Okay, so we have seen that before collision and after collision. Okay, now by law of conservation of momentum, total momentum before collision is equal to total momentum after collision, right? So by law of conservation of momentum, by law of conservation of momentum, total momentum before collision is equal to total momentum after collision. Okay, so here total momentum before firing is equal to total momentum after firing. Total momentum after firing, right? So what about the total momentum before collision? That is equal to 0, right? Then total momentum after, what about the total momentum before firing? That is 0. Then what about the total momentum after firing? That is MV, capital M, capital V plus small m, right? So total momentum before firing is equal to total momentum after firing. Okay. Now I am taking this term into this side. Okay. So it will be minus. So minus capital MV equal to small, right? Okay. Now this we want this V. So I am taking this next side. Okay. So it will be V equal to mu divided by capital M, right? Their multiplication. So here minus is there, right? So this or we can write V equal to this minus we can take into this minus we can take into next side. Okay, so minus mu divided by capital M. Okay, So this is the recoil velocity of the gun. So V is equal to minus mu divided by m, where V is the recoil velocity. Recoil velocity means the velocity with which gun move backward during firing. Okay. So small m is the mass of the bullet. U is the velocity of the bullet, and capital M is the mass of the gun. So by using this equation, we can find out the recoil velocity. So here you can see that one minus. What it indicates? Minus sign. Minus sign indicates that the gun is moving backward. The velocity is backward action. That is why it is minus. Okay. So you know that is it is the opposite of that, the movement of the bullet. Okay. So this is known as recoil velocity. I hope all of you understand this session. You can download lesson notes through link which is provided in the description box. We can meet in next class. Thank you.